Dean Kenny is one rink master. He designed and built this massive 450 square meter backyard rink for his grandson and the neighborhood kids. And today, I'm helping him on his quest for the perfect ice rink.
So next we'll put our leveling system in now. You want to grab the bolt.
Got it.
And we want to make sure that you put the 2x2 up against the bolt. The 2x2 is actually going to sit right against this bolt. Now that's the same around the whole rink. That will stop the pressures that are applied from the water. The force is being applied out. It'll stop the boards from moving. And it plays a dual function. We can also line the boards up vertical. If you get the persuader there,
right on,
and drive this in, we can get on. I'll show you. That's it. Keep her going. Yeah.
So this is ingenious. I mean, not only is this a monster backyard rink, it is engineered to withstand everything.
Well, Al, the goal is to have the rink one man set it up or take it down in 10 hours. And that was the goal, and yeah, we achieved it. There's 2 levels that we want to check. The first level is we'll see how the board is this way. And we're looking pretty good.
This could come up about a millimeter.
Well, we're not making watches, okay? So we're good that way.
Okay.
Now the next thing is we'll want to check the level this way.
Right.
How does that look there, Al?
That level looks pretty good, but I bet we could bring it down a hair.
Just bring it down a bit. Well, you can see, watch this.
You step on that and the bubble moves the way we want it to.
All right.
So
if you can pinch it now, and what you're doing, Al, is you're actually pinching the 2x4s against the 2x2. And that'll hold that on there quite nicely.
And with the addition of the last screen, it's time to check out the ice.
Nice rink, Dean. This is good looking ice. How did you make this?
Well, Al, we have a liner. We drop the liner down. And of course, just add water. 7,500 gallons of water. That gave us roughly 5 inches of water, kind of like a wading pool, if you will. I have some rough surface areas, and I have some spots that didn't freeze right through. There's some liquid underneath there that's just not frozen yet.
Kinda like what we have here. Where did it start freezing?
Well, it started to freeze from the top down.
What do we have underneath?
Water.
And what else do you see on the surface here?
Yeah, it's kind of got a raised section right here.
It's like mutant ice.
That's right.
It didn't freeze level at all. Freezing bulk water, large volumes of water, is tough to do. So this is where I'm going to show you the scientific secret, help you understand water and ice that will help you build perfect rinks. Dean, you ready for a little lesson in thermodynamics?
Yes.
Okay, this is a bottle of water. Use the infrared thermometer to tell me what the temperature is there.
-8.
Okay, so it is super cool. It's cooled 8 degrees below its freezing point. Watch what happens when I give it a little shot. Okay, now, see it freezing?
Yes.
And what's happening to the temperature gun?
The temperature's going way up. Wow, 2 degrees.
It went from -8 to -2.
-2 degrees.
In how long?
Seconds.
So as the water froze rapidly, it gave off heat very rapidly. So why would freezing water turning into ice, give off heat?
You're the science guy.
Okay, how do you melt ice?
By applying heat.
That's right. You put heat into ice to convert it into a liquid. If you want to take that liquid and put it back into the ice form, what does it have to do with that heat?
Got to displace the heat.
The process of freezing liquid water into solid ice gives off heat.
So, Alan, how do I make the perfect ring?
Well, the starting place is layers, small volumes with high surface area, so that heat that's produced during the freezing process is easily dissipated to the atmosphere. When you build up your ice in small, thin layers, the layers rapidly freeze, and they freeze smooth.
Al, just one last question. Should I be using warm water or cold water to flood the rink?
It's not super critical, but if you can get warm water, it's better. 2 reasons.
Right.
First thing warm water does is it melts the top of the old ice just a little bit, gives you a better bond between your new ice layer and the ice below. The other thing that's good with warm water is because it doesn't freeze right away,
Right.
it has a little more chance to spread out, get into the cracks, and give you a little smoother ice surface.
Cool, let's play hockey. Okay.